We're essentially going to do 14.2 and get that started. Basically, we've seen this, but we're going into more practice, more detail, and what are called descriptive statistics. These are numbers that you would use to try and represent some property or some useful attribute that a population, a group of people might have. And we have quite a lot of them. And we have the mean. Remember that one? You add them all up and divide by how many? And we have the mode, which is the one that causes the most trouble, not because it's the hardest, but because of the rules about when you do and don't have a mode. And then we have the median, which is the middle number when they're in order. And there's two versions of that. Depends on if the data is got an odd number in it, like 5 numbers or 25 numbers, or if it has an even amount like 90 or 8 or something. And then we have a guy called the standard deviation, which is done on the calculator. The range, which I think we haven't talked about yet, but that's pretty easy to do. A guy I know we haven't spoken about, which is called the interquartile range, IQR for short. And here's some more descriptive statistics. And these guys are called 5-figure summary, min, Q1, the median, which is also called Q2, Q3, and finally the max. And the 5-figure summary is very often collected so you can do one of these guys. Right, so you can create what's called a box plot. That's one of the reasons that we collect that, at least. So let's just start up with these 3 guys first. So we're going to look at, again, the mean, mode, and the median. Yeah, and I'm going to write down my list of numbers. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we would write down n equals 10. That's the letter that we typically use when we do statistics to represent what's called the sample size. Right? And you can have a story attached to this if it helps. I'm just randomly giving some numbers. But okay. I'm having issues with WebAssign again. Oh, darn it, in space. He knows how good I am at not swearing. I've got this window with all your pictures right in the middle of where I want it to be. I don't want it to be there. I want it to be over here. Okay, that's it where it needs to be. Right, so focused on 10 numbers. To calculate the mean, and I'm doing this by hand. I'm going to do these guys by hand, and then I'll show you how you can do same guys using the calculator. So you got your calculator. This is just kind of add together. 1, add 3, add 4, add 5, add 8, add 11, add 12, add 18, add 19, finally add 23, and I get 104. Divided by 10 numbers, and that ends up being 10.4. And that guy is called the mean. And you will also see that that guy, the mean, uses this symbol, which you read out loud as X bar. So if you ever see that symbol, it means the mean. So the mean of this data, let's pretend that this is how many coins people had in their pocket. So you got 10 people and you asked them to check their change. And these are the 10 results that we got. And that's our first fella, the mean. Now, to get the mode, And I know you don't really need to rewrite these numbers, but I want to do it. You would pick the most popular number. I have deliberately made every single one of these numbers different. And when there isn't anybody at all that's more popular than anybody else, what do we write down for the answer to the mode? Can you remember what the word we used? Somebody quote me on this if I'm wrong, but I believe you write in the word none. Now, if there had been 2 8s, that's all it would take, right? Suppose same data set, but there was 2 8s. Wouldn't the mode be 8? It was more popular than any other number. Even although it was only a little bit more popular, it still won the prize for being the most popular number. What would we do if there was 2 7s and 2 8s, right? So it was like a draw. What was the rule about what you said the mode would be in that case? So you get 2 7s, right? You get 2 8s. What do you do?
The answer will be none.
The answer's still none, right? So the mode's a bit messy because of those rules, but as long as we stick to the rules, we are good. Well, I don't need to, but this is, again, because I want to, and it allows me to write on things and keep everything a little bit separate. To get the median, right, you pick the middle number when they're in order. Well, there were 10 numbers. So if you divide that by 2, you get the 5th number. And this is where the problem starts. 1, 2, 3, 4, 5. But if you count from this side, 1, 2, 3, 4, 5. About half the time that you do this, isn't there going to be 2 numbers in the middle? Right? So if you had 10 numbers or 8 numbers or 42 numbers, there's going to be 2 guys in the middle. And when there's 2 guys in the middle, we still have a median, right? It's not like the answer's none. There still is a median. Can anybody remember what single number we use when this happens? We don't use 8, we don't use 11, but what number do we use instead?
We add them and then divide by 2.
And I believe if you do that right, you get the answer 9.5.
Yes, 9.5.
So are we comfortable about how to do it by hand? How to get the mean? You add them all up and divide by 10. How do you get the mode? Well, you just look at them. If there's more one number than anybody else, that's the mode. Median. Put them in order. 5th guy, 5th guy, there's a draw. If there's a draw, you share out the value. But you know, if there's 9 numbers, won't the thumb be the middle number? So when there's 9 numbers, the median is the one number in the center. I'll make up an example of some data. 1, 3, 3, 5, 6, 11, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? There's 9 numbers here. The median is guy number 5. 1, 2, 3, 4, 5. That guy there is the median. Can you see he's 5 from the right and he's 5 from the left? Isn't he bang in the middle, right? The middle number, that's the median. So when you've got 9 numbers or 11 numbers or something like that, there's only one number in the middle. So whatever it is your answer. We're good now? Now, we want to do as much of that on our calculator as possible. You can get the mean and the median on your calculator. So let me now show you that guy. I'm going to try something here. It might work. If I'm really lucky, it will. Are we looking at a big picture of a TI-84?
Yeah.
Yay, okay. So that might be a little bit easier to see than my hand version, right? Because you can't always see all the buttons. So what I'm going to take you through now is that same set of data, and I'm going to show you how the calculator can be used to get the mean and the median. As far as the mode goes, you just have to eyeball it, right? There isn't a calculator for the mode. So I guess I'll switch on my calculator. And then I'll hit start. And I'm going to choose option 1, which is called edit. Right, so I switched it on, I hit start, I'm looking at the screen, and number 1 is edit. So I go down to enter and I press it. In my case, it's nice and blank, which makes my life easy. So what I'll do is I'll now type in the numbers. So it's 1, 3, 4, 5. 8, 11, 12. 18, 19, and 23. Oops. Right. Now, I'm about to hit enter, but just before I hit enter, do you see that L10, that little 10 there?
Yeah, it's a number of numbers.
Right. So if I know that my data should have 42 numbers in it, nobody's going to give you that, by the way, but pretend they did. Shouldn't that last guy say 42? Because if that last guy says 41, didn't you miss one? And hopefully you can find it and just tag it onto the end. So I know that looks good. So there we go. So what I've done is I've got my data, right, my numbers into the calculator's memory. So it's happy now. So let's find the mean and the median and whatever else we want, right? So I'm going to go start again. Now it's pointing at edit. I don't want it to point at edit. I want to move it over to this guy called calc. So you go over here and you hit that button. And you see if you hit it, it moves along to the right. And if I hit it this way, it moves along to the left. Okay. Now I'm going to hit it once to calc. And the option I want is nice. It's already there. It's option 1. And that's short for 1 variable statistics. So that's what I want. 1 variable statistics. And then I hit enter. And it depends on what kind of TI-84 you've got. I've got an old one, so I have to type in a little bit more. Some of you have a different looking thing where you've got a little menu. I've seen them, they look like menus. Has anybody got that menu version that I'm talking about? No? Okay. Then 1 variable start. All I need to tell it now is where the numbers are, and they were stored in L1. And it's not very clear, but you see above this button 1, there's a blue L1. So you hit blue button 1, and that's how you get L1. Right? Blue button 1. And so if things are working out correct, you should have 1 variable starts, L1. If that's what you see, hit enter. And guess what? We have got lots of stuff. We have, for instance, the mean is 10.4. Remember, that's what we got before this started, right? 10.4. If you want to add up all the numbers, it came to 104. That was right. If you want to square them and add them up, not that I'd ever want to, but if you wanted to, that's what it would equal to. These guys are standard deviations. N equals 10, it tells you how many numbers were in it. Now, I want to see some more stuff, because right now, all I found out is that the mean is 10.4. But I also want to know what the median is, sometimes called Q2. So you go to these buttons here, and as you press them down, or you press them up, see how you scroll through them. Now, if I keep pressing until I can press no more, I'll get like the second page. And in the second page, there's the median. Remember the 9.5 that we got? That's where he is. Are we good with how the calculator is going to reduce our workload? Right. There are some questions you have to do on the calculator. You could do the two that we've just done, right? The mean and the median by hand, right? You could still do those by hand, but there are other things like standard deviation, for instance, that you couldn't do by hand. It wouldn't really be practical. Are we good so far? Right. So if I kind of return to my kind of hit list of things that I want to make sure that we've covered. Are we happy? We know how to do those three things, right? By hand or with the calculator.
Can I ask a question, please?
Sure, Nadia. What you got?
I have done a previous question, and right now I don't know how to put all new numbers which you are operating now. How do I delete them, please?
Okay, gotcha. So if you're going to be using your calculator a lot, you're going to have the problem of, but my calculator's got numbers in it and they have to go away, right? You have to delete them, just like you said. Are we looking at my calculator screen again before I continue? Can you see a big calculator on the screen?
Yes, I can.
Okay, right. So what I'm going to do is clear the data away, right? So I can put in new numbers. So hit start again, go to number 1, edit, and you'll see all those numbers. Do you see the guys?
Yeah.
Right here on the top row, there's a button called DEL. It's short for delete. It's like the backspace, I guess, on your keyboard. If I hit that button, do you see every time I hit it, one of the numbers disappears? And if I hit it enough times, they all disappear.
Okay, thank you very much. Now I deleted it.
Right, and the next question, we'll put in some more newer numbers, right? And we'll, go through the process again.
Thank you very much.
Seems you're arrived, Tara. Okay, so what we're going to be doing is basically doing descriptive statistics today. We've covered these, which are old stuff, but we've done them before. I want to show you now how to do a 5-figure summary, and then I'll do these guys next. So if we're going to do a 5-figure summary, I guess we need some data. And I don't know what I'm looking for here. Here it is. Looking for my special pen. So I'm going to collect some data. I think we'll let you lot supply the data, so it's at least real world data. And we're going to create a 5-figure summary, is what its fancy name is, which is basically these 5 numbers. Well, we did ages last time, didn't we? How many siblings in your family? Let's do that one. So you count yourself and any brothers and sisters that you've got, right? So it's up to you if you want to take part in this, but I'll start. I'm one of 10 children, so there's 10 of ours. Anybody else want to join the list?
There are 5 of us in my family.
3 and 5 works. Keep going.
Another 5.
Another 5.
3.
It's not a very big data set. I probably could do a few more. If you don't, I'll add members of my family.
6.
So you got 6, okay.
4.
4.
And that's a second 4.
Good.
And 4 again. Yeah, there we go.
1, 2, 3, 4, 5, 6, 7, 8, 9. Now that's a decent size, right? For the shy people amongst you, can I put a 1 in? Somebody here is an only child and they felt left out, so I voted for you, right? Now, this set of data, I could get the mean, the mode, and the median by hand. The mean would be just add them all up, divide by 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. So 10. Oh, didn't realize I'd done 10 again. That would be no problem. If I scan through it, would you agree that there are 3 4s there? So there would be a mode of 4. I'm not going to do any of those. I'm just talking through what I would have to do. The median is a pain in the butt one. I cannot find the middle number in this list. At least not the way they're written. Wouldn't I have to rewrite them from smallest to biggest? Right, so I'd start with a 1 and then a 3 and a 3 and a 4 and a 4 and a 4. And that would be, you know, ain't too bad with 10 numbers. Do you really want to do it with 100 numbers? Nah, wouldn't be practical. So we are going to do a 5-figure summary. So we're going to get the minimum, a guy called Q1, a guy called the median, which we already know about, who's also sometimes called Q2, a guy called Q3, and the guy called maximum. And again, this is, okay, come. Right, so calculator should be visible. I'll hit start, choice number 1, and I'll put in my data. So it was 10, a 3, 2 5s, a 3, a 6, and 3 4s and a 1. And 10 numbers, yep, perfect. And I'm going through the same stage that we did before, because all the guys we want, all the statistics as they're called, are in the same place. So start, move over to calc, choice 1, 1 variable statistics, and then blue button, 1. Looks good. And in this case, the minimum, well, you won't see them yet. If I scroll down to the bottom, we have a minimum of 1, a Q1 of 3, a median of 4, a Q3 of 5, and a maximum of 10. Did that feel a little bit more smooth the second time you've seen it? That you kind of just do the same thing each time you put in the data and then you get the statistics that you're looking for. And these happen to be the 5 statistics. This is called a 5-figure summary for pretty obvious reasons. Now, let's build one of these box plots, right? Using this data. And I just realized I should have probably drawn my line a bit lower, so I'll do it again. The numbers go from 1 to 10, but I would start at 0 because it seems a natural
Can I
place.
interrupt you really quick to ask
Yes.
you a question?
Go for it.
It's about the calculator. So I finally figured out on my 36X how to do it. I knew I could. So I
Okay.
did figure out how to do it. But then I'm trying to read the symbols that they have. And when you went through that, it was a little bit too quick for me to write it down. Because like I have the arrow up SX equals, and then I have like I have all those weird things that it's saying, but I don't know how to translate what those actually mean.
Okay, I will return to my screen and Can I
Does
talk you
that make
through
sense
them?
what I'm asking?
Yeah,
Like, I'm
yeah.
getting confused.
Right, here we go.
Yeah, so
You
this
see that
is-
X with the little bar atop? That's the mean. That's written down as X bar, but it represents the mean. Okay? These guys
Gotcha.
here,
That's so much easier. Okay, so X with the bar is the mean.
correct. This thing here is sigma X. You don't need to care about it. It just means what you get if you add them all up. This is sigma X squared. Don't care about it. This one here is a standard deviation, right? That S with the little x, S for standard deviation of X's, the data. And we're not using that yet, but we will later. Obviously, and that guy there you can ignore, but if you want to know who he is, he's the population standard deviation. That is 10, meaning there's 10 numbers in the data. And if I scroll, I think most of the others are pretty self-evident.
Oh, I found it. It says Q1 on it now.
Oh, okay.
Now I'm starting to see.
Min,
Okay, now that's starting to
Q1.
make way more sense.
Right, median, Q3 max. So these guys on the second page, as I call it, these are the 5-figure summary fellas.
Thank you very much. I was
Not a
getting a little
problem.
bit confused.
This is one of the situations where I think being physically in class would be so much easier because I could just sit beside you and say that one there, you know, or whatever. Right, let's return to our little guy. And we've got 0, 1, 2, 3. We're going to finish at 10. And then we create what's called a box plot. They kind of look like this. So the smallest number was 1. So I'll put a little mark there, just a little vertical mark at 1. And the maximum was 10. So on that same line, put the finish. There's your min. There's your maximum. Q1 is at 3. You draw typically a line twice as big. The median is at 4. Q3 just happens to be at 5. And then to finish, you join these guys up to make a big box. And then these two little guys here, they just get a line. And this is called a box plot. And what it is essentially is a little visual representation of all this data. Now, once you get used to looking at these, they tell you lots of quite useful things. See that guy where I'm pointing right now, right? The Q2 guy, the median. Can I say roughly that the typical size of family in this class was 4 children, right? You and 3 others. The smallest was 1, the biggest was 10. And these two guys here, which are called Q1 and Q3, if you ignore everything else and just focus on that box, 50% of this class has somewhere between 3 and 5 children. So it kind of gives you an idea where the middle chunk is, right? The middle 50%, somewhere between 3 and 5 children. Half the people in this class, that's how many they have, including themselves. And I kind of like, once you get used to it, can you see that if I add extra lines here? Can you see that the data is really broken into 4 chunks, 4 quartiles? From here to here is where the first quarter is. From here to here is the next quarter. From here to here is the third quarter. And from here to here is the last quarter. So I can tell you, for instance, that between 5 and 10 children, 25% of the class has about 5 to 10 children in the family. And if you want to do the bottom 25%, between 1 and 3. Right? So there's lots of visual pictures in that. It's called a box plot. I prefer a name that I have, not one of my made up names, but I prefer it. It's sometimes called a box and whiskers plot. And I kind of like that name. Do you imagine the box with a little whisker sticking out? It kind of helps me remember any name that helps me remember something I like, right? So box and whiskers is a better name, in my opinion. Are we comfortable with how to do the calculator to find a 5-figure summary of numbers? And then how to take that and build one of these box plots?
So anywhere like where you did the dotted lines, I just want to make sure that my notes are legible later on. So each of those, so it wouldn't matter where that box falls on there. If you're going from where the first one is to where your Q1 is, that's going to be 25%, no matter how much of the line it is.
Yeah, it can be a
With
skinny
each
line, it
one
can
of
be a
those-
big line, it's 25%. And then the next one is 25, the next one is 25, and the last one, no matter how big it is still 25. It just means that this is very spread out, right? Quarter of the class has family in this size, but you know, there's somebody at 5 and somebody at 8 and somebody, and it's all spread out. Whereas over here, there's a lot of 3s and 4s. That's why there's quite close together. Yeah, that's better. I can see now. Like somebody threw a handful of sand in my face. Right. Are we good with box plot? You feel comfortable with that? Do you want to see another one created from scratch?
Can I ask a question, please?
Yes. What you got, Nadja?
Why do we have like 4 quarters, like each of them like 25%? Why don't we have one part 30%, another like 55%?
Well, the way that these were created was to be the same all the time. So if you move the lines around, right, you made this a bit wider or crushed it up a little bit, you would get what you just said. But then every box plot could be different and you wouldn't be able to interpret it the same way. I'll give you an example. Suppose I had 2 classes, and this is, say, from 0 to 100, right? Obviously 50 in the middle. And the first class had a box plot that looked like this, and we don't need to worry too much about the specifics of the numbers. And the second one had a box plot and it looked like this. If I wanted to compare those 2 classes, because we do Q1, Q2, Q3 and max and min the same way, I can look at those 2 classes and I can make certain assumptions about them. How about this assumption? Would you agree that the average in both classes is probably about the same? Not much difference, right? The typical person in the middle would be the median. So I would be saying right there, right? Would you agree it's about the same place? But the red class, isn't the red class much more spread out in their scores? Some people got like 20 odds and some people got 100. What about the green class? Oh, that's not so spread out. Would you agree that the green class is much closer, tighter? So this would be a class where, although the average might be, I don't know, let's say that's 60. The average was 60. There was a lot of variation in that, right? Some people were getting 30, some were getting 90. In the second class, the average was 60, but there wasn't a lot of variation. And so making it so that these represent quarters allows us to make a valid comparison. That's one of the reasons we do it. And it's always going to be 25, 25, 25, and 25. It's not any other number. The way they're created, that's what you get.
Okay, thank you.
I think we'd come to the conclusion that that fellow was fine. You know how to create one of these, and I'm cool with that. So I'll check these guys off, right? So I've got these fellas. I guess I should give them numbers. 1, 2, 3. These 3 numbers typically measure, right, a typical person or score. These numbers measure how spread out the data is. So can you imagine you could, just like that story that I had a few minutes ago, couldn't the mean of both these classes be the same? The mean of class, the red class is 60. The mean of the green class is 60. But if we had some number that we could use to represent how spread out they are.
May I ask a quick question, please? Can you show me the page that you had? Driana stole my phone, so I couldn't get a picture of it. And I really wanted to make sure what I wrote matched. Thank you.
Is it this one here?
Yes, I was
Okay.
looking at the standard deviation and range. My notes that I already wrote on it were not quite making sense.
Okay,
So,
so we're going to get some numbers, right, called standard deviation, range, and interquartile range. And what these numbers are going to do is they're essentially going to tell us how spread out the data is. And each one of them does the same job, but they do it in slightly different ways. So let me focus on these three guys. We've got a guy called standard deviation.
Can I watch a movie with Zizi?
She thinks it's easy, Tara.
no, she wants to know if she can watch a movie because it's nice outside and the rule in the house is you can't turn the TV on. So she thinks if she stands here and steals my phone and ignores me, that I'm going to let her have TV. I'm a mean mom.
Nothing wrong in being a mean mom.
I didn't think so.
They are the best kind. Okay, so we are going to find standard deviation, range, and IQR, and these are measures of how spread out things are. Right, so I'll just make up some numbers. I'm going to have two comparison classes, right? So I'm going to call them class A and class B. I'm not going to put very big data sets in them just so that we don't spend forever on the calculator. So in class A, they got a quiz out of 10, and the scores that they got there we go. That's 6 numbers in that data set. And the other class, well, they got that. I am going to just mute you all for background sounds. There we go. So remember, hit the spacebar when you want to ask a question. Okay, so here's my two data sets. We are going to calculate the standard deviation, the range, and the interquartile range, and we're going to do it using the calculator. And so essentially, I'm going to have to do it with two data sets. So you won't see these for a few moments because I'm going to go over to my other screen where the calculator is on it. Here it is here. And I'm going to go on and hit the start button, hit enter, and I'm going to have to get rid of all that data. There we go. And the first one was 5636. So 5636. And then 7 and 1. And I'll move over to the other side, and it's going to be 5566 and 44. Now you notice I put one set of data in L1 and I put the other set of data in L2. This is sometimes easier than rubbing out the first one so you can put in the second, because you might want to see both of them at the same time, right? And so I can look at them and see them together. So once your data is in, L1 is going to be class A and L2 is going to have all the stuff with class B in it. What I can now do is I can hit the start button again, move over to calc and choose one variable stats, just like we always did. And I want blue button 1. And when I hit enter, here is the data, but we want standard deviation this time. Now, standard deviation is this guy here called SX. It's S is short for standard deviation and X is for data. So it's really trying to do in 2 letters a lot of words, right? So it's the standard deviation of the data, SX. In this case, I don't want to write all those decimals, so let's write down 2.25. Okay. Now, I need to get the range, and I also need to get the interquartile range. And although you can't see it, I'm writing this down as we speak. The range is the difference between the maximum number and the minimum number. So in this case,
So I'm a little confused at what we're making notes of, what that we're writing while we're doing this. So I want to make sure I got it.
when I finish doing this, I'll bring back the screen with the
Okay.
notes I'm saying, so you'll see them that way. Right, now to get the range, you take the biggest, the max, and subtract the smallest, the min. So max take away min is called the range. In this case, it's 7, the maximum take away 1, and I got a range of 6. And then the third one out of the 3 is called the interquartile range. And you get that by taking Q3 subtract Q1. So it's just a formula. Q3 is 6, Q1 is 3.
And that equals what again?
That's called the interquartile range. So what,
Interquartile,
right, what I'm going to do,
right?
yeah, I'm going to go back to my screen now and just show you what I was writing as we're doing it. Right.
So, IQR.
The standard deviation is SX. That was 2.25. The range was the biggest, max take away the minimal. 7 take away 1. In this case, it was 6. And the interquartile range is the guy Q3. Remember this guy here, Q3, take away Q1. And in this question, that was 6 take away 3. So the answer was 3. So standard deviation, range, and interquartile range. Are you happy where those numbers are coming from? Are we good? Right, now I'm going to go back and do the same thing for class B, right, the second class, because they have a data set as well, and we have to work with their numbers. Now, I'll just show you where that data is again. There's start, edit. You remember the stuff that we put in column L2? That's class B, that's what they got. Okay, so here we go. Start, calc, choice 1 again. There's only one little difference. It's not L1 that I use now. What column shall I use for the second class? It's not L1. Who do I use?
L2.
Thank you, L2. Now to get L2, it's blue button 2. Right, L1 is blue button 1. to get L2 is blue button 2. So what that's going to give me are all the numbers I need from class B, the second class. And the standard deviation this time is roughly 0.89. Right. And the range, well, I have to scroll down to get the range in the interquartile range because you get them from here. The range is 6, take away 4. The max, take away the min. So the range is 2. And the interquartile range, well, that's Q3, take away Q1. And that is 6, take away 4. And that is also 2. So I'll return to my screen and we'll show you those guys.
So when I do it, I basically just get L2 and then the numbers, but the stats don't show up. Am I doing, I don't know what I'm doing.
Are you on the TI-84, Taryn?
No, I'm on the 83.
But it's a TI-83.
It's a TI 83 plus.
Well, that should be fine. So, well, these are the numbers that I've got, but you're not getting those. So that's what you're saying, right?
Well, no, so it's weird. I put what you said in with the second and the 2, and then I get an L2, and then in parentheses it says 5, 5, 6, 6, 4, 4, but it gives me nothing else.
Okay. I want you to hit the stat button.
Okay.
Move over to the calc button.
Okay.
Are you looking at one variable stats right now?
Yeah.
Okay, hit enter on one variable stats.
Okay.
Now, blue button 2.
The blue button is just second, right?
Yes.
Second 2.
Are you
Oh,
now?
there it goes. Thank you.
Okay. Maybe it was just one missing button. Blue button is now second button to you.
Okay.
I think in some calculators it's yellow, so go figure. It's not even the same color. Right, that's pretty much us for today. So let's just have a quick recap. If I wanted to compare these two classes and I just wanted to look at how spread out they are, can you see that this class here has got a interquartile range is 3, where in this class it's only 2, and this has a range of 6, and this guy has only got a range of 2. Can you see that these are bigger numbers than these? And what that's reflecting is that this set of data is much more spread out than this set of data. I think just eyeballing it, would you agree that these are more spread out? You know, look at these numbers. They go all the way from 1 to 7. They're a lot more spread out. Aren't these numbers all kind of compact, 4, 5s, and 6s, all, you know, like crunched together? So when we find a measure of how spread out they are, that's what these guys' jobs are. Out of the 3 of them, the range is the worst. It's not very accurate. The standard deviation and the interquartile range are much better. They tend to not get distorted by just one exceptionally big number. Although the standard deviation does get distorted a bit, the interquartile range is never distorted really by exceptional values. Are we good on that first half of today? Do I need to do anything else with this bunch of questions before
So I
we
have
start?
a question. I was working
Yes.
on one of the problems just to see if I can make sure that I'm really getting it.
Right.
So the range that I got is perfect, but it's saying the standard deviation is wrong. And I checked all the numbers. Everything is exactly the way it's supposed to be. So
Would you check that the standard deviation that they wanted was the population standard deviation or the sample standard deviation? Right. Did they want an SX? Right. Did they want an SX or did they want the one above the SX? Because there's two
This
versions of
just says
standard
find
deviation.
the range and the standard deviation. It gives you the 5 numbers.
Right.
And then it just says range and standard deviation on it. It doesn't say anything else.
Okay, what question number was that? And we'll try it.
Number
together.
8.
Okay, so let me go at 8. Okay, everybody, we're going to show you another quick version of this fella. This is,
Yeah, because I did it right on number 7, which is like basically they just gave you one number, it's like 5, 9, 9, 5, 9, 6, 9, 7, 9, 8, 9, 9. And I got it right on there, but then this one has a bigger range. So I'm trying to figure out what I might have done wrong, but everything is exactly what it shows on here.
okay, I'm going to see if I can have both things together at the same time, because it's a little bit easier. Do you see the calculator and homework together in one screen?
Yay!
Okay, let's just keep our fingers crossed. Right, so we're going to do that set of data, right? That happens to be my set of data, right? So I'm going to go start, I'm going to go edit, and I'm just going to get rid of these numbers because they're just distracting us now because we've got a new data set. And so it's going to be 83, 93, 101, another 101, and we're going to finish with the 102. And it's saying here the range. Well, I can do the range just looking at it, would you agree?
Yeah.
But the standard deviation is probably the one that didn't work anyway. So let's figure out what went wrong there. So hit the start, go over to calc, one variable statistics, hit enter, do blue button 1. Oh dear, yeah, I hit the thing twice. I don't know how I done that, but I did. Right, there we go. Blue button 1. Right, now, as you see here, there's 2 different standard deviations. The one that we typically, and it's the only one I would be expecting you to use, is the 8.121. So I would be typing in 8.12 with that data set. Now, if you look below it, do you see there's a funny looking one with an X on it, this thing here? I'm just wondering, I'm not saying it's true, I'm wondering if the standard deviation they're talking about is this one. Right, so you've got yours in front of you. Type in your number and see if it's that one, and if it's not, type in the other one, see if it takes that. That's the only thing that could be wrong. There's nothing else that could be wrong here.
All right, I'm just putting it in.
Okay.
I'm waiting for it to go through.
Okay.
Okay, so this one, yeah, that went through then.
That one's okay?
Because the first one, it wanted SX, but the second one that I answered wanted that other number. The A.
Okay,
whatever
you
that
just,
weird
right,
symbol.
you're just going to have to live with that idiosyncrasy, that since you get 5 shots, if it's not the SX one, on your
Might
second
be the
shot,
AX.
write the one underneath it. The difference between those two is that one is a sample, which all of these to me are samples, but if you consider these numbers as a population, in other words, that's the only numbers in the universe to do with that, then I guess you could say the second one would make sense. But I would be talking about the top one, in my opinion. Okay, let's return. Are we good so far then with everything that we've covered? Is there anything you want me to touch on before we start looking at some with what do you do in the homework kind of thing? Okay, so I can hide that guy probably. Are you now looking at just the homework? Has the other guy gone away? Okay, let's make it a little bit bigger. Here is your small data set. mean, mode, median. Do you agree that's pretty standard? Do you know what you're being asked to do? Mean, mode, median, same again, same again. Might have to shrink this one up a little bit. Right. From this set of data, aren't you going to have to get your 5-figure summary? And once you've found your 5-figure summary, one of these 4 pictures is going to be your guy. Now, the only difference between the way I did it and the way they did it is, do you notice at the end I do little vertical lines and they do dots? That's just cosmetic, right? So you're going to find a 5-figure summary, and then from that 5-figure summary, you're going to draw your picture, and then you're going to look at your picture, and it should look like one of these guys. So that will take a bit of time, but that's how you're going to do it. And here's a range in standard deviation. Another range standard deviation. There's the one you had trouble with. Range and standard deviation. And what I've been saying is that when you do the standard deviation, if it's not the SX one, will you choose the one underneath it? Because evidently that's the one they were looking for. Are we good up to that point? Do you feel comfortable with those questions? Aubrey.
I have a question. So I did one of the problems at the top, and it keeps saying that it's wrong, even though it should be right.
Which one is it you were doing? What question?
Number 3. You want me to tell you my numbers? Because they're different from the ones that you have there.
Okay, hold on a second. Okay, I'll clear this out.
I put it in the calculator too, and it said the same thing, and I put it on there, and it kept saying it was wrong. Still.
Okay, what was the data set?
Okay, so mine was 71, 82, 99, 80, and 88.
So I'm going to go start.
And it keeps saying that my
Edit.
median was wrong, which is 99.
The
right?
median. Okay, let's move along. One variable start. Blue button 1. And our median is 82. What did you get for your median?
I said 99 because it's in the middle.
Oh, well, the median is that guy. Now,
Because it's
when you say 99 is in the middle, what do you mean? Do you mean that you added them all up and got the mean was 99?
no, like for yours, DC 75, 86, 103, 84, 92.
Yeah.
So 103 would be the median, right? On yours? Or am I thinking of the wrong one?
I think you might be doing the wrong thing. I'm not quite sure what you are doing, but the median is 82. That's the bottom line. For the data set that you gave me, that's
What would
it.
yours be? For yours though, what would yours be? On that one, on problem 3?
On this new set of numbers?
Yes.
Well, I'd have to go back and change those.
So I don't know if I did something wrong.
Well, it's easy to hit one digit wrong and you end up with, the wrong number somewhere. One number wrong can very often. Now, see, I was about to hit that and got it wrong. Sometimes you forget, as I have just done, to rub out the old data. So you might have a number left from a previous question. That could happen too. So I got start, I'm going calc, I'm doing the whole back to front stuff. In my case, the median would be 86, which would be that number, which is correct. This data is not in order. If you put it from smallest to biggest, that 86 would be bang in the middle.
Oh, you have to put it from smallest to biggest?
Yes.
That's why.
That's what went wrong. Okay, we
That's
figured out
why.
what went wrong. Yeah.
Okay.
But
Thank
if you use the calculator, you don't need to put them in smallest to biggest. The calculator does that for you.
Okay.
But if you're doing it by hand or eyeballing it, they need to be done that way.
It makes sense. Thank you.
So we're going through these guys, and I think I got the answer that we are good, right? Up to where it was,
Or-
question
yeah.
10.
Yeah, we're at 10. Because
We're
10
at
just
10.
stumped me and just said everything I did was wrong.
Well, it's just the numbers are huge, so be careful. All you need is to do 9-3 instead of 3-9, you know?
Yeah.
And remember that these are separate numbers, not billions or anything, right?
Well, and I'm wondering, because it says on the information, and you said it's X with a line over it, is the mean.
Correct.
Are you sure?
Oh yeah, I'm sure.
So my calculator says 522, and this thing says no way.
You're right. Well,
But
I can't
did
say
it
you're right.
by hand. I did it by hand and the calculator, and I'm coming up with the same number. So I'm
Well,
like,
the mean is the X bar with the thing on top. I mean, I guess I could go through these numbers and type them in and show you that's what it is, but my data won't be the same as yours, so I won't get the same number.
no, I'm just trying to make sure that I'm consistently getting the same stuff when I'm putting
If
everything.
you type in only the numbers that are in your data set and you type
Oh,
them
I
in
think I
correctly,
know what. No, those are okay. So on that thing, are those thousands or hundreds? Right? They're each divided.
oh, yeah.
I
Oh, the
think I
little
know why I
darlings, I
screwed
missed
up.
that. Yeah, I did the same mistake. It's actually
did the same thing.
217.
Oh my
Yeah.
gosh, I could not figure out. I'm like rechecking it. I'm like, I have 10 numbers. I have 10 numbers. I did this.
Yeah.
So then I did it by hand and it still was wrong. Those are
If you
thousands.
look really
my
closely,
gosh. I didn't
yeah.
see that.
If you look really closely, do you see the commas are black?
Red and black.
That's
Right.
why I was
Secondly,
in the
I should have
number.
noticed that last digit, right, that last number.
Well, just goes to show you when
Should
you
be
make
big.
217,000, 21700, it's not going to work in math.
Okay, true. Right, let's continue. What we have here is just a data set where the numbers have years attached to them, but that doesn't really matter. You just use, what, 5, 6 numbers and you get mean, mode, and median. This is a little bit easier to see what the numbers are because it's a column, right? So you can imagine 275 and 305 and 230,000, right? Big numbers, but mean, mode, and median. And one of these numbers is which one of these numbers, that's what the measure means, is the best home price. I would not be choosing the mean. If you look at these numbers here, do you see this weird house here at 2.5 million? Wouldn't that make the average price like twice as much as everybody else's? So that would have been a bad choice. I would probably pick the median in this case. Here is a whole load of data on nutrition bars and why you shouldn't give your kids any, or myself included. And take the data as a column. And if you've been asked to do serving size, then you get your numbers from this column. And if the question was about how much fat, you would get them from that last column. Once you've got those 3 fellas written down, won't you also need to get the 5-figure summary to figure out which one of these? Have you noticed I've done their box plot the way I do them? Instead of little dots at the end, so it's cosmetic. And not only that, you get the mean and standard deviation. So this last question basically gets you to do everything. Mean, mode, median, 5-figure summary, you know, everything else you could think of, including a box plot. So I guess if you can do question 14 correct, then you should be able to do everything correct. There's only one thing I haven't covered, and that's question 11. And it's easy to skip what I've done or haven't done. You might look at this and say, oh yeah, 4 numbers, put them into the calculator, mean, mode, median, we're done. It's not as simple as that. There isn't a single 22,000. There's actually 4 of them. So if you're doing it in your calculator, 22,000, 22,000, 22,000, 22,000. Then it will work, right? Easy thing to miss. Right. So 4, 7, 8, 9, there's 10 numbers there. They've just been condensed into a smaller table. And as long as there's not too many of them, that way works fine. How are we doing, guys? Happy? Right. Let's move on then to our second fella. I'll close about 5 windows so I can do that. I didn't mean to hit that. Go away, go away. I hit the wrong number, hit the wrong thingy. Now I've lost my window. Brilliant. There we go. This next kind of thing that we're going to deal with, let's get that out of the way. I'll kind of show you because it's very visual and it's going to take a little bit longer to do. It's not that it's hard to do so much as it's more time consuming. So I'll do one by hand and then we'll show you what it would look like. There's a homework question. Suppose we have a table and we have number of siblings, right? And percentage. And then a third column, which I'm not going to go into quite yet, cumulative. And we collected data on lots of people. And there's 1 child in the family, there's 2 children in the family, 3. It takes, as I say, it's more time consuming than hard. Thankfully, you don't have to do the tables. Right. Just to make my life and your life a little bit simpler, can we imagine that on the data we collected, the biggest family size was 8? Right. And instead of telling you how many people, they converted it into a percentage. So, screen. So 12% had 1 child in their family, right? 12% of the entire sample was a 1-person family. And then it went 13%. Then this went 20%. Then this went 25%. So what's we got? 10, 20, 60, 70, 80, 20. Let me just check I did this right. 5, 10, 20, 30, 40, 50, 60, 70. Perfect. Right, so you can look at this table and you can say, oh, 5% of the people, 12% of the people asked had 5 children, including themselves. So what's this new guy called a cumulative? Well, that first answer is 12%. But the second answer is what you get when you add those 2 together. And the next one is what you get when you add those 3 together. And then the next one. Oh, God in Hamill. Should work. Count my count. There we go. Glad I fixed that. That's 70, not 80. Now it's good. 82%, 90%, 95%, and then finally 100%. Do you see how we created the cumulative one? Now, what this number tells us isn't how many had 6 in the family. This number says 90% of the people had 6 or less in the family. And 70% of the people asked had 4 or less in their family. Do you see that cumulative way is just a different way of aggregating, putting together the data? And it's sometimes helpful to do that. If you do it correctly, which is why I had to double check this one, shouldn't this be 100% at the end? Right, because this would mean everybody, at least in this data set, right, had 8 or less children. And that's a cumulative frequency, and that's essentially how you do it. So I'm now going to show you what that looks like.
Professor, do you think you
Yes.
could please explain how you got the percentages?
Oh, they were given to us in the question. You don't create them.
Oh, okay. That makes a lot of sense. Thank you.
You have to be told them, or else I guess you could collect them by going out and asking people. Right, now, the guy that's new is this table here. Do you see the percentages are given to you, right? This one here is the number of bedrooms or homes in a certain, you know, like East Bremerton, whatever. Oh, studio. Yeah, Ant Studio's not really got bedrooms. You know, your bedroom and your living room is the same room. Yeah, some of you might live that way because, you know, I was poor once. I was a student. I was poor before I was a student. Anyway, 5%. Oh, you notice they do the percentage for you, so that makes life easy. 16. 44. 78. 93. 99. And 100. Are you all happy about how I figured out those numbers? Right?
So as I understand, the number is always ascending, right? Like
Correct.
bigger, and that's that biggest one.
Yeah. Are we cool with that cumulative guy? It's a new guide, you know, but it does what it does. Now, when it talks about mean, median, and mode, they are talking about the red numbers. Okay. Now, how to find the mean, median, mode from the table? If the answer does not exist, then you enter it. Now, that is going to be a little bit more difficult. And the reason for that is that we have to calculate a new mean. And it's not one that you're going to get from the calculator. It is called a weighted mean. So I'm going to go back. Yeah. And the reason why it's a weighted mean is, do you know that this data was percentages? It wasn't exactly, you know, 5 people had 4 bedrooms and 6 people had 8 bedrooms, right? It wasn't raw data like that. And that means that when we try and find out what the average number of bedrooms in this area is, it's a little bit more awkward. So I'm going to write down the number of bedrooms again. And I'm going to have to cheat on that last one, which they really shouldn't have, but it's too late now. I'm not going
So
to.
when you're
Yes.
doing the percentages right there, that, so you're just showing it where we're gonna re-put in that new percentage that we're using so that we can come up with this new number, or where are you coming up with those numbers? I just want to make sure that I kind
These
of have.
percentages are an exact copy of what was on the table in the picture. I
Okay,
haven't
so
changed
that's
anything.
their numbers that they give us.
They are
not
numbers
the
that you're going to
percentage,
get.
not the cumulative.
Right.
Okay.
So how this is going to work is you're going to find 5% is 0, 11% of 1, 28% of 2, and I'm bored, so I'm just going to say and finish with 1% of 6. So it's basically a weighted average. So it's these percentages with these numbers, and this here. Oh, okay, why don't I use this box to put these answers into, right? So if I did 5% is 0, it's still going to be 0, right? And that guy is going to be 0.11. This guy here is going to be 0.56. This guy here is going to be, what is that going to be, 9? Too hard to do in my head. Right, 3 times 0.34, 1.02. There we go. This guy's 0.6, this guy's 0.3, and this guy's 0.06. If you add all of these numbers up, right, you will now have your mean. So it's 6, nothing, 12, 13, carry 1, 4, 10, 50, 10, that's 1, 1.5, 1.6, 1, 2. There's your answer, 2.63. So this new mean is taking all the information about a number and what percentage was that number. Calculating what the percentage, like what's 34% of 3 get you? What does 15 of 4 get you? And you add it all up. There is your mean.
Oops. Can you go back to your table that we, well, I don't know if everybody else wrote it, but I always write your tables. So can you show me that on the one that you did with the 1 through 8, where we did the percentage that you gave us, and then we just were working on the cumulative.
Oh, you want to do this
and
one?
then show it on the one that you did, because then my notes will match and my numbers won't be so weird, because I think I got what you said, but it's a
Okay.
little sketchy.
Sure. Let's see what we can have here. Right, this one here is the siblings one, right?
Yes.
And this is a created table. And what I'm going to do is I'm going to take this table and we're going to find the mean, right? So in this table here, I'm going to go 1, 2, 3, 4, 5, 6, 7, and 8. And I'm going to find 12% of 1, which is 0.12. I'm going to do 13% of 2, which is 0.26.
So are we just converting the percentages into decimals then?
Yeah, that's the easiest way to do percentages. Think of that as 0.2.
And not off of the cumulative percentage, but only off of the true percentage.
Yeah. That's why
that's
guy.
way easier. I thought it was something complicated.
Oh, I think this is still pretty complicated.
It seemed way more complicated like 2 seconds ago when you were writing it. I could not figure out.
As I said, again, it is very time consuming. It's not so much difficult, because if you look at it, aren't I just doing the same thing over and over and over again, like 8 times? And the last one is this one. This is just a convenience for a very long calculation. So 2, 8, 16, 21, carry 2, 6, 7, 8, 9, 2.9, 3.5, 3.6, 3.7, 3.8, 3, 4. So the average number of siblings in this particular family data set is about 4.81. And that's a weighted average based on percentages.
Oh, I got 1.1.
Well, I'm assuming I did all my calculations correctly. Okay, I'm seeing less happy faces. So I think I should try really slowly for the last one of these. One more example of that situation happening, right? So let's do number of vehicles in family. So you went to some place in Bremerton and you collected data on the percentage of cars. So you went to one house, 0 cars in the family, 1 car in the family, 2 cars in the family, 3 cars, and finally 4. So the data set's nice and small. And the percentages ended up being 15%, 15% again, 40%, 20%, and 10%, right? And what we would like to know from this data, right, is the average number of vehicles in a household. Right? So if you went to someone's house, you know, in your street at random, what would be the average number of cars in that family? Now, the way you get it is 15% of 0, 15% of 1, 40% of 2, 20% of 3, and 10% of 4. You add that up and you get 1.95.
Oh, so that's 80. Okay, so I have to type.
Does that make sense in how I calculated the mean from this table? Are we good on that, or do you need to see another one? Are we finally happy with these tables and how you get the mean out of? I need feedback from you lot. I got a good. I'm happy with good. Oh, because sometimes they like to do things differently. Can you imagine a question where it's not a percentage but a proportion? So 0.15, 1.15, 2.4. Will you realize that a proportion and a percentage are just two ways of saying the exact same thing? So if they did it this way, wouldn't the answer be 0, still 0.15, and 0.8? In fact, in a lot of ways, isn't that easier because you just multiply them together without turning one of them into a decimal in the first place? Now, that's only one out of the 3 things. That's how you get the mean from these kind of data. Right? Okay. So what I want to do now, if I can, is return back to this data. And don't know what the mean is, but let's find the mode. Now, the mode is the most popular answer. In this table, the most popular answer happened 25% of the time, and that answer was 4. Are you comfortable about how I figured out what the mode was from this table? The biggest percentage is the most common answer, Biggest percentage is 25. What was that? That was 4 children. 25% is 4. The mode isn't the 25% part. The mode is the number it's pointing to. It's the 4. Does that make sense? Okay, in this table over here, which one would the mode be now? This table here. Agreed. The 3. Right? 34%, bigger than anything else, and the thing that had that was a 3. Are we good with the mode? Because you really don't need to do much except look at the table. Suppose you got a different table and it wasn't a 25 here, but the biggest was 20 and 20, right? So you got it twice. What do you do if there's 2 answers to the mode? Well, you don't cut its head off, Tara. That's a bit violent. So what do you do instead of cutting the head off?
You
You
say
say-
none.
you
There's
say none.
nothing.
It's none, right? And
Or
you're-
in
you're
this
good.
thing, I think it's D and E or something.
DNE, right?
That's you put
Whatever
up.
they ask you to call it.
It's
right?
done.
It's done.
Chop it off. Done.
Okay. Which means there's only one guy left. And that's going to be that's going to be the kicker. That's going to be the one that you might find a little bit clunky. And that is the median. Now, in English, isn't the median the middle number? Right? Now, this time you do use the cumulative. And it's kind of in 2 steps. The first step's pretty easy. Would you agree that the middle number is position 50%? Right? Now, as I go through this data, when I get to this number here, right? When I get to 3 siblings, it's 45%. And when I move on to 4 siblings, it's all the way up to 70%. Right? Won't the 50th percent one be in this group here? It doesn't matter which one of the 4s it is, isn't it still going to be a 4? And that's how you figure out the median. Right? It's the middle number, it's the 50th percent. Now,
That's not
Oh.
one where we have to do like 3.5 on it, right? It's not 3,
No.
but it's not
No.
4. We would
it-
just write the 4.
it's just a 4, right?
Okay.
Now, I wish I'd done this table a bit better, but never mind, I can squeeze it in. I'll do it in red. Here's the cumulative one, right? It goes 15%, then it goes 30%, then it goes 70%, then it goes 90%, and then it finishes with 100, right? If I wanted to know what the median is in this table, right? Can you see that the 50th percent mark, when you get to here, you're 30. And when you get to here, by the time you finished, you got to 70. So isn't 50% in here? And so the answer would be 2 vehicles. Does that make sense, how you calculate the median from these tables? You find out which number would have 50% in it, right? Where would you be if you were in the 50% mark? It's always typically right inside one of these groups. That one finishes at 30, right? This one finishes at 70. So wasn't it one of the 2s that was at the 50% position? Let's try one all the way through, right? Do all 3 things on this one. Hopefully that's enough to call it good. So, oh, I don't know what we're going to do here. Maybe I could pick one of their stories. Okay. These are the sizes of glue. Evidently, you can only buy glue in certain sizes. And you can have a 2-ounce tube of glue, a 6, an 8, a 12, or a kind of jumbo 16-ounce glue. And we have proportion. Sometimes it's a percentage, sometimes it's a proportion. And then you have cumulative. And just to be really awkward, the cumulative, they want it to be in percentages, which is fine. So this number is 0.28, 0.12, 0.35, 0.06, and finally 0.19. And we are going to use this table to find the mean, right, that guy, the mode, if it's got one, and the median, which it will have. And I'm going to do them out of order. I'm going to find the mode first, because I don't need this to figure out who the mode is. If you scan through this list, which number is more popular size glue than any other size of glue?
Eight.
Agreed. Are you happy where that came from? Do you see it's 35, 8? Don't need to do anything else. In fact, couldn't you have just done it with just that table? You don't need any other piece of information to get the mode. Just the table's good enough. Let's do the median. Right, that is 28%, right? 0.28 as a percentage is 28%. Remember, decimals and percentages are just two sides of the same coin. Now that's add another 12%. So are you happy where the 40% came from? Then add 35%, then add 6%, and then add 19%. If you do it correctly, shouldn't that last answer be 100%? If it's anything else, check your count. Now, to be the median, don't you have to be the 50% person? Now, as you scroll down the cumulative numbers here, which one of these numbers, 2, 6, 8, 12, or 16, which one of these numbers would be the 50% number?
Would that be 8 again?
It would be, by sheer coincidence, it would be 8. So far, so good. Now, to get the mean, I'm going to have to bend this piece of paper. This guy. Because you can't really do this, you know, in the stats menu, right? You got to just do this by hand, which kind of slows us down. Don't I want to find all of these multiplications and then add them up, right? Remember, that's how we get it. So it's going to be 2 times 0.28, which gives me 0.56. And 6 times 0.12, which is 0.72. 8 times 0.35. And that would be 2, 4, 2, 2.8. 12 times 0.06 is 0.96. And 16 times 0.19. Well, I did good until I hit that one. 16 times 19, that's 3.04. Now, see if these questions had been percentages, 28, 12, and so on, wouldn't I still be doing the same calculation? Wouldn't I still be going, you know, 28% of 2, which is this guy? Now, add this up, we get 8, 14, 18, carry 1, 10, that's 1, 1.8, 2.5, 3, 4, 5. So I get a mean of 5.08. So the three guys, getting the mean is going to be the most time consuming. Right, we're going to do I just don't feel quite ready to finish it. So let's do this one. I'm going to give you one to do, and you're going to do it first, and then I'll go over it. And if you get the same answer, then I'll feel comfortable about calling it, that we've got this. So, because I can't think of any decent question. Number of coins in pocket. And this time we'll turn it back into percentages, because sometimes you get percentages, sometimes you get proportions. We'll keep the data set nice and small. No coins, 1 coin, 2 coins, 3 coins. I guess I'll have 4 because I've got space. And it's going to be 10%, 15, 30, 25, and finally 20. And your job is to find the mean, the mode, and the median. Okay, you got 5 minutes. Find the mean, mode, and median of that data set.
Professor,
Yes, Nigel.
can I ask a question, please?
Sure.
So, for example, now I have calculated everything and I wanted just at once right away to clear all datas. So I did it, and how do I exit? Because I'm pressing clear button and I cannot exit this menu.
Okay, so what you want to do is on your calculator, you'll see the second button. In my case, it's blue, and right next to it in blue, can you see a word called quit? So second, and the button right next to it, second mode button. And if you hit that, you should be able to get out of anything that you're doing.
Thank you very much.
Okay, let's go for this, guys. Well, fingers crossed this is going to work out. Watch out for me screwing up as well. Let's do the mode first. If you scan through that, would you agree 30% is the most popular? So how many coins in the pocket was the most popular number? Agreed? 2. Say that again, right? 30%, but the answer is 2, right? 2 coins. Now, I'm going to do the cumulative. So this is 10%. Then you add this, you get 25. You add this, you get 55. You add this, you get 80. And for good measure, you finish on 100. That's a good sign. Now that I've got the cumulative one, which number will I be on when you hit the 50% mark? Because that's where the median is going to be.
2.
2 again. Agreed? Somewhere in here, which is a 2. And now the ugly one, which is why I'm going to bend my paper again. To get the weighted average, we find 10% of 0, which is 0. 15% of 1. 30% of 2. 25% of 3. And lastly, 20% of 4. Have you noticed that in each of these cases, you turn the percentage into its proportion, its decimal equivalent? Because that's easier to work with. So 5 and 5 make 10, carry 1, 9, 16, 2.2, 2.3. I make the answer 2.3. Does that match up with your answers, I hope? That's a good sign, because pretty much all they're going to do for this group of questions is, change the tables. Sometimes it's percentages, sometimes they give you its proportion. But if you think of these as being really the same information, it doesn't matter which
So
way
we don't
you
need
write
to
it.
divide those then. We just put
No.
that number in. I did a whole nother step in there and I divided it. And then I came up with this weird 46 from my 2.3 instead of just leaving.
That probably explains why you shouldn't have done the divide part.
So no division this time.
Technically, you divide by 1, but that doesn't help because it doesn't change the answer.
Why would it only be 1 where before when we were coming up with that number, we had to divide by
Well, yeah, the reason for that is that these are not real whole numbers. These are percentages. And what do you get if you add up all the percentages? Don't you get a total of 1?
Yeah.
So you're
Huh?
really just dividing by 100%, but 100% is 1. So that's kind of the logic behind it. But since dividing by 1 never changes anything, we just ignore the whole process and say, the number you got is the final answer. You're done, right? One less step to do, always good idea. I can't remember if we said it, but will you now say hi? I think this is a nice natural place for us to finish for today. I'll hang a